Looking forward to discussing all things scale with you, Aurimas. And as I do that, I would like to hear about your journey to scale. Where did you start from? What was your keen interest? How did you make into this particular area or industry? And how do you keep it going? There's so much to consume and so much to learn.
Yeah. Okay. So a little background from my side. So I've been in data field for the last 10 plus years now. Actually, I haven't been anywhere outside of data. Not necessarily anywhere outside of data. I have been doing some cloud engineering and DevOps engineering. But initially, I started as a data analyst. Then I kind of moved to being a data scientist, then machine learning engineer, then data engineer, then led some teams of data engineers. Then we started building our data platform team. So we built a data platform. From there, naturally, a lot of skills were needed in DevOps field and cloud engineering field. So I ramped up in those. Then I started leading a team of cloud engineers as well. And eventually I decided to take a break from leadership roles and went on a hands-on sabbatical. So it was my previous role where I was doing a full-fledged hands-on machine learning operations engineering. So infrastructure for ours to use, our data practitioners to use. And now actually a few months ago, I started a new role as a solutions architect for Neptune AI, where I'm consulting clients regarding their own in-house machine learning operations stacks and how to best integrate with Neptune. And I also have my side gig, let's call it. So I'm also a founder and CEO at Swirl AI, where my goal is to actually educate people around concepts in data field. I do believe that the correct way to do it is to learn about the end-to-end process. So from data generation till deploying models and serving users, right?
Yeah.
And the scale part of it, it was all around the place. So naturally, the first scale that I saw was once I jumped to data engineering role. I was very lucky to actually do that in a company which actually had big data. So that was a point in time where I started actually deeply learning technologies like Apache Spark and Kafka and how the big data flow actually works end to end and how to scale that. And since I was doing machine learning and data science before that, I also integrated very well with machine learning teams in the company and kind of had the chance to also touch that part of scaling. And eventually, of course, it led to cloud engineering, where I also touched the part of scaling software and not only machine learning. Of course, machine learning is software, but regular software.
Yeah. So, Aurimas, to be very frank, I used to think till date that full stack data scientist or full stack engineer is a myth. Now I'm talking to you, I'm realizing what part of this whole life cycle have you not touched? You've done all bit of work.
Yes.
I think it's a whole life cycle you have done. Yeah.
Yes. I've done the whole life cycle. Also, that's also why I think that I have I'm not necessarily advantage, but thing or qualities that are needed to teach people the end-to-end life cycle. And I do see lack of it in the education industry or field where there's not that many people who can do end-to-end and connecting data engineering with machine learning.
Yeah.
So I do plan, not do plan, but my goal is to also touch those parts. And if teaching, then teaching how the transition between one discipline and another discipline happens, so that there's no like hard cut, and then you need to gather information from different parts of the internet to actually learn it, right?
Yeah, absolutely. And now that you're telling me that you've touched upon this as part of what your job role entails, like certain part of your job might have asked you to kind of deliver certain work, and hence you kind of picked up onto that technology or how to deliver, like you're saying, you're scaling not just the algorithmic side, you've learned how to scale software as well, and then how to integrate everything so that it comes together, which is, I think, the core focus of operationalizing the software, not just traditional software, machine learning software, which is the pain that the industry feels today. Now, when you do that, and I have read a lot of your LinkedIn posts, to be very frank, and the first thing that catches my fancy is that you are so very well able to make everybody visualize. So that component that you, I think it requires a lot of research from your side, or maybe a lot of effort in creating that content, because I think it's not easy for you or for anyone else to just not depend on their historical knowledge or what they've learned on the job, as well as look for that information out in the public domain, curate everything together, and then kind of simplify it for the reader, because that's the job that you are doing for all of us, right? So when you do that education part, how do you think that learning happens by just gathering the knowledge nugget from somebody who has already done that, or it's something that we always have to get our hands dirty, have a practical side of it? Now I've understood, okay, maybe our Aurimas is telling me something through those newsletter post and everything. How would you enable somebody to go from that point to what you have done actually already by yourself?
So that's a complicated question, right? So you always need a hands-on part of it. So you can't just learn theory and just start implementing it.
Yeah.
So you do need to do projects to learn, right? So I do also have plans I'm already preparing some hands-on material so that you can actually implement everything that I'm talking about. But I still don't have decided on the form it will actually take. Like it could be a course, it could be a boot camp. I'm not sure yet. But what I want to say by this, that just by reading what I post, you will not be able to implement real life.
There's a
right?
Supplementing material that somebody needs.
Yes, and my goal initially was not necessarily teach you the basics of it, but rather allow you to skill up in the disciplines. So if you're already doing part of it, I know that from my experience, that even if people, for example, are deploying models, or they are training models, or they are data engineers, they don't necessarily have that broad knowledge of the entire lifecycle. So my goal initially was to allow people to skill up, and I'm not talking only about basics. I'm also talking about some fundamental qualities that are also sometimes also skipped in how people learn things, right? But now I see the gap that is missing, meaning teaching people not only the basics of it, but initially the basics of it, and then how can you improve what you do, like adding monitoring and logging correctly and scaling the applications, which are also usually not taught either in the boot camps or courses that you have online.
Yeah. And in fact, I would say that, no, please go ahead.
Go on. So maybe for now, if you are reading my material and you want to actually start implementing it, you will need to find some additional material for that. But in the future, I'm planning to cover it.
Yeah, and the fact that you whatever you are already doing or you've achieved, I think I somewhere read your post that it's been a journey of last 7 to 8 months that you've been sharing a material, and the skill that you've already achieved in terms of having the trust in the system, that people trust you because you have already done that. It's coming from experience that you're speaking. There was already a gap which you have covered, which is a very big thing. So I would first like to congratulate you for that, because it's a big thing. Every time I see your post, I know that this is serious stuff, or maybe this is purely technical things, which is currently a mess because right now it's not been covered anywhere else, and it's coming from your experience. And definitely, like you're saying, whenever you're going to roll out a boot camp or anything else, that would be a very, very good, top up on the kind of information that's already made available by you. So that's quite a journey. Like it's like a phase 1 you've already done, and then you're already looking for phase 2. And then that brings me to the question: how do you get so much of time?
So how I started it was more of a not that much of the time required. So I started it by spending around 1 hour per day. But my initial posts were not as visual as we are now. They were definitely less time consuming. So that's one thing. Another thing is that as mentioned, I either did it already. So I kind of, before even writing, I already have in my mind what I want to tell. So I don't need to do that much research. But then when you start touching upon more complicated topics, I definitely then need to because I have either done it hands-on or I have read a lot about it if I write about it.
Okay.
So even if I have read a lot about it, I still need to reread some things so that I don't lie to the people that are reading.
Yeah.
So now it usually takes around 3 hours of my time to do one quality post.
3 hours?
If I want to dig deep into that concept. For example, even if it's a Spark topic, I still need to remember and fully ensure that this setting, for example, is actually doing what I'm saying it's doing, right?
Yeah.
And then there's a graph. The graph itself usually takes at least an hour my time to do, because I don't even start writing a post if I don't have a graph before I start writing. So if I can't do it without the picture, if I don't have a picture, then I think it's not kind of quality enough for me.
And it's difficult as well because you're just using the words to explain a concept. It's not like you are having a live audience in front of you where you can use whiteboarding and anything else. So your visuals or the picture that you're seeing, actually creates a connect where somebody first looks at it, understands it, and then goes back to the content and try to relate it. But 3 hours if you're putting in a day, I think that's a huge commitment you're already showing to the community.
Yeah, so some of the posts you probably already can see that some of them I'm reposting because 3 hours per day it's a lot.
Yes.
Imagine.
Yeah.
But I'm still spending that time to pre-write my newsletter. Sometimes now newsletter is coming first before I actually post the content. And in the future, I also plan to have a separate stream of newsletter where I would actually dig deeper, analyze data systems on a more granular level, maybe even building out the entire, let's say, web tracking system or recommendation system, but not only the recommendation system part of it, but how the data is collected and how do you do it end to end. But that would be some additional yet work.
Yeah, definitely. But now that you've talked about data systems, let me go straight to that. And, whenever we talk about scale and from the software engineering lens, if I have to put it, people talk about data architecture straight away. And I personally think that data architecture in itself is a very broad term. So what I want you to, understand from you is how do you break it down? What all components come under this?
So for me, data architecture is still the data system. So it's not necessarily related to 100% related to the software engineering system, even though it's connected. You need to, so you need to define the data model inside of the business application already before it actually reaches the first touch point with the data system, which in my mind is a place where you collect the data. So it could be implemented in different ways. For example, one of them is naturally a CDC connector to a business database. It could be CRM database, it could be marketing database, finance database, but something that is populated by the backend services of a specific, usually function or team in the company. Another way of looking into this touch point is collection of, let's say, web events, so web stream events. This could be a specific collector application. It could be Google Analytics, but I am usually trying to look from it as if we wouldn't be using any like third-party solutions to implement it. So in my mind, it's still a collector. So an endpoint, public endpoint exposed to the public internet, which can be then targeted by your JavaScript application, for example, in your website, and it would generate those events and then push them to this collector, and then the data pipeline starts. So this is the one part of it. So the connection between the systems that generate the data. Then if it really depends on the scale you're at, but I'm also trying to always think that we already have a scale, right? Because if you don't have a scale, it could just easily be a database dump that you ETL down the stream, and then you just populate your data warehouse. But I'm interested in these larger scale systems where you will always see a Kafka or any other distributed messaging system as a first touch point with the data that you are being collected. So if it's a CDC stream, you're populating Kafka directly. If it's a collector, you will be pushing those events to these Kafka clusters or any other distributed queue, right? So these events, currently there is a lot of debate going on around data contracts and data quality, right? So what data contract ideology says that these data contracts should be implemented at the source. So meaning that given an example of a backend database of your product, that would mean that the developer who is actually building the product would already implement some semantic meaning to the data that he is storing in a backend database. And those would actually be kind of represented by events that are being written to the database. And those events would be then pushed out to those distributed messaging systems via CDC stream. But we already know that this event has been modeled in some way that it would be useful for downstream analytical purposes. So this is this part, another element. So let's say we have a contract with the developer who is then, of course, discussed and planned with analyst or data scientist who would be using the data. So you have a contract, so a specific entity or event. You have a point that connects these events with your data system. Then you have a distributed queue that allows for high throughput and transmits huge amounts of data. Then you decide on what kind of architecture you need. So either it's a Lambda or Kappa, right? Usually those two are the ones that are most popular. So if your data is okay to be pushed to the batch, so to the downstream systems in batch, then you do Lambda. If you need real-time data, you do Kappa, right? So then there is the next layer, which is basically you dump your data into, if it's a Lambda architecture, you dump your data into data lake or data lakehouse, they are currently called, and you either model it in there directly, or you do some really heavy transformations in the data lake and load those that transformed data into your data warehouse.
Okay.
So then from a data warehouse, you naturally probably, so data warehouse is then split into 3 parts probably. One is staging, where you actually load the data, stage it for further transformations, then you fill your master data, so middle layer basically. And then from that master data, you construct your data marts that are then used by downstream consumers. Either it's an analyst or a data scientist or other data professionals. Usually you would have one data mart specifically created for feature stores. So you would mount a feature store on top of this data mart, which was modeled with the help of data scientists or machine learning engineer who knows what data they need in their machine learning models. Then feature store system would be populated with it. We could define some transformations inside of it. You create some feature vectors, representations that are then used by machine learning engineers to train their models, and from a different API to serve those trained models in production. So this is the flow. We can cut off the batch part and do everything in stream, meaning that instead of having data lake and data warehouse, we can simply have a stream that directly feeds analytical systems. Either it's a feature store or a real-time dashboarding solution of some sort. But ensuring data quality and SLAs in the stream is a challenging endeavor. So usually you would choose lambda over kappa unless you need your real-time data 100%. So your business case could be depending on it, right?
Yeah.
And now these are the pieces. Of course, in those pieces, there are a lot of other elements, how to ensure the quality, how to scale each of them. But I don't know, should I, how should we continue?
I'll do that part. I have a lot of questions and I'll do that part to take it forward from here. So the point when you mentioned, I think the very first point was related to data model. So let's go a little deep into data model to the extent that what does it mean? What is its significance? And is it prone to change? Like, can that model keep changing over time?
So usually also you have to do a decision here. If you want to model your data as a denormalized model or a normalized model. Denormalization is pretty popular, I would say, nowadays, where you would actually have dumped the data in your data warehouses that are not that well modeled, meaning that it could be in the form of events, and then you only do some modeling on top of it, like extracting some dimensions from it, but not too much. However, the usual case would still be that you would do data modeling in a sense that you would still implement the regular normalization forms in your data warehouse. So you would extract you would model your entities, you would model your dimensions, you would model your facts, you would model your dimensions in you would need to understand what your dimensions are, like are they changing, are they static, and you would model your tables accordingly. So
and how would you define dimensions?
101. So dimension is just a property, or not a property, but a set of properties of a entity. For example, if I'm a human being, I will have my name, my surname, my personal code. So these would not be changing that often, right? And then I would be performing actions. So I could be buying the things, right? These are facts. So you want to distinguish between those because you don't want to do additional unnecessary updates to the huge table that has information about the facts and the dimensions in it. So you would basically just extract the dimensions away and have those statically defined. However, some dimensions are changing. So let's say we could have my name and surname most likely will not change, but it could. So it's already a slowly changing dimension, right? My tastes for things could be changing, right? I could be loving apples today, but my favorite food tomorrow could be bananas, for example, right? So you usually but model your data and understand what kind of dimensions you're modeling, and you could even have separate tables for slowly changing dimensions and separate tables for non-changing dimensions, because for slowly changing dimensions, you will need to have additional fields that will identify, for example, when the dimension has changed. And you will always probably need to, not probably, but the truth is that we are always interested in history, meaning that we'll always want to know at what point in time those properties had specific values. So you will need information like when this property has changed. Is it still the active property? And once you have this information, then you will be able to join it to the facts. Facts will have their own dates, and you will need to know at what point in time which dimension property was actually in force, right? So that's why you need all of that.
Actually, and when you mentioned that these are slowly changing tables, so there are two ways I assume the things happen, right? One is that you have a certain attribute or a dimension of any entity, for example, the nature of which is changing over time, for example, like your preferences or taste or behavior, right? And what happens when you have an additional dimension added to an entity, which is now defining it more comprehensively, holistically, then does it also count under slowly changing table?
So dimensions can be, dimensions will have their own tables.
Okay.
For example, I am a dimension as a person, and I can have my properties defined in a single table, but it could span more tables, right? So if
okay,
yeah, there are many ways to model it, but I wouldn't really go into depth of today.
Yeah. And when we say the active behavior is changing, who monitors that? Like, who is responsible for that? Is it done through some automatic behavior change? So something which captures that change?
So there are many different ways that this could happen, but usually if you have a very good data system, so let's say your backend databases have a information about your user, right? So what you would actually do, you would capture all the changes automatically. But then again, some of the dimensions could be extracted, for example, from a third-party sources that you don't really have control of. So you would need to poll for changes, basically either do a daily ETL by extracting the third-party source and seeing if a change happened. Some of them could not be that convenient to work with. For example, they do not provide a timestamp when that property changed. So you would need to assume that, for example, the time of when we extracted it was the time of change. So it's either manual or automated. So automated the way could also be implemented by doing a CDC connection to one of the product tables, let's say a user table with its properties. So once a change has happened, it automatically is pushed to your downstream system. Of course, it will not be, if it's a batch system, which it's most likely is, you will not see the change immediately, right? It will take you 4 hours, let's say, from emitting of the event till you actually see it in your data warehouse.
Yeah. And Aurimas, tell me one thing, when you mentioned about data model and we started talking about normalized and denormalized one, right? And then we were talking something about feature stores as well. So whenever in the entire data system or a pipeline, data goes through certain transformations, like we are normalizing it, we are standardizing the data, or some data processing needs to be done during different stages. And I believe that's the part where those transformations, depending upon how heavy duty they are, they'll kind of become a bottleneck for how soon you get the eventual data out of that pipeline to the downstream consumers. So when that happens, how do you start first? Like, do you first take the downstream consumer as the first goal in your mind, and what kind of latency, and somewhere you at one point you mentioned throughput as well. So at what level are they expecting your data to flow? Then you take it backward, and then you optimize your pipeline one by one, and you kind of, how do you diagnose which particular part is very heavy for data processing, which you need to trim down?
Okay, so yes, usually SLAs are defined by business needs, right? So it could happen that the data from, for example, events happening in your website that were happening yesterday have to be in your system at, let's say, 7 a.m. or 6 a.m. And we have to be present for automated reports, as an example. And once people come into work, analysts want to work with the data that is already full for the last day, as an example. So you have these SLAs defined, and then you decompose your entire pipeline into pieces. Because if you're like, usually data engineers will be responsible for the entire of it. So both the ingestion part and the ETLs and the data warehouse part of it as well. So if you can decompose it, you can very easily see how much time it takes for a event to actually be, once it's generated, to reach the end of it. And you decompose it then into a streaming part. So how, when the data is piped, then you have the data lakehouse part, and then you have the data warehouse part. So it's not really that hard to understand which of the systems is the slowest and is the biggest bottleneck, and then you can nudge some properties of it to be faster. For example, you usually don't stream data into your data warehouse. There is possibility to do that, but you would be outputting your events first in data lake. And how you do that is you first buffer them into memory. You serialize them into formats like Parquet. Usually it's Parquet. Nowadays you won't see ORC that much. And then you dump these batches of data into your data lake, and then after you take them and transform them down the stream. So batching this data is also a process that can bottleneck. So for example, if your streams are huge, however, your data is not that big, you can imagine, for example, having a Kafka topic with 30 partitions, and you only have handful of events coming in. And then it could happen that your application that is reading the data from it and buffering it and outputting to S3, as an example, works on a partition basis. And it only emits the data once you say, let's say you have a Parquet file of 64 megabytes, right?
Okay.
And if there's not enough data to fill those 64 megabytes, it could happen that the data is in the buffer for an hour or 2 hours until it actually reaches those 64 megabytes. So this is one of the examples of the nudges that you can change. So you could, for example, either decrease the size of your stream, because it's not always that you need to have big streams, right? And that would make your buffer fill faster and not have less delay until the data is actually dumped into the stream. Another case could be that the stream itself is a bottleneck, so it's too small. The buffering happens quickly enough, but the writing into the Kafka is the bottleneck, and the events are delayed because of that. Or the stream is large enough, but the scale of the application that is reading the stream is not large enough, and then it starts lagging behind, and you get an hour or 2 hours of lag because it's just not keeping up with the amount of data that's coming in. When it's in the data lake already, then there are usually you will be using Spark applications to do some ETL on top of it. So you could battle it if you could battle the latency with just increasing the size of a Spark cluster, but usually it's not necessarily the best way to do it. You can optimize your Spark applications to implement either a caching strategy of some sort, or maybe your files are simply of a size that is not optimal, or you're using formats that are not optimal, like CSVs instead of Parquets, or maybe you're not using a layer on top of your data lake like Hoodie or Iceberg or Delta Lake, which can also solve some of the problem.
Okay.
Yeah.
So just tell, so whenever in this entire cycle of nudges, I can say that there are multiple components that you can tweak around to make sure that you are able to meet the required SLAs. Is there a rank order through which you do that? Like, let me try this first, and this is the most important. Like, for example, when we are talking about Spark cluster, optimizing it is more important for me. Is there a hierarchy that we need to go for? That this should not be touched upon. Whatever comes next, maybe the size or the format or those things can be taken care of. That's first question. And the second one is, for example, when you were talking about the Parquet file size and those things, right? If you need to trim it down, maybe from 64 megabytes to something, does
you
it
don't
require
never
a manual?
you never trim it down to less than 64. But Go on.
But
Sorry for interrupting.
are those manual interventions required, or is there a, like we generally talk about auto scaling and also those increase, decrease kind of things? Do they happen on their own when the system senses that this is how the buffering is becoming a problem? So does somebody actually need to manually come and make those changes?
So usually, like, there are best practices of when it comes to some of these, like the size of files that are landing in your S3 bucket. These are definitely best practices, like 128 megabytes. Just go with 128, and it will, in most cases it will be fine. Some of them can be, some of the nudges can be automated. So I've done like Spark cluster auto scaling. It's hard to do because if you're doing aggregations in Spark, for example, it is usually not linear how the system scales in comparison to how much data it actually has to process.
Yeah.
But it is linear in some bound. For example, if you're using EMR cluster, which you can spin up and kill on demand, so you can choose either you have, let's say, 4 i3 8x large instances in the cluster, or 6, and usually between 4 and 6, and the amount of executors that you can fit into that cluster, there would be a linear change in how much time it takes to process the data. So you could kind of do this smart, let's call it estimation, that counts, not counts, but yeah, it counts that amount of, not the amount, but the size of files you need to process. And you know how, in which time frame you need to fit. So you can kind of, in a certain bounds, you can estimate that. So you could automate a script that reads your S3 bucket. It knows how much files are there, and then according to that, it scales your EMR cluster. When it comes to Kafka, it's the distributed queue. There are offerings that are better at this and not that good. So, for example, Google's offering is serverless. You don't even know how many shards, let's call them shards, are in the system, because it doesn't expose it to you. So as much of data as you push into it, it will auto scale automatically and will be able to process. When it comes to Kinesis, for example, which is the AWS's offering of distributed queue, you need to scale it yourself. So you need to decide on how many shards you want to have in the stream. And each shard can take a amount of megabytes per second. And there's an amount of reads that you can do. If the data is very dynamic, like you could have very little amount of data in the morning and your traffic like ramps up in the evening, you can't do that easily, like scale up and down the stream itself, because there are penalties you get from scaling the stream up and down. Like, first of all, it takes time to scale. Then you create some intermediary shards that take some time to disappear. Then some of the clients that are reading from these Kinesis streams might not be dealing well enough with these facts. So you usually want to have that fixed and keep it at least for some time. You could scale them up and down seasonally, like if your traffic is lower on summers or winters, then you could do it, but then you want to probably keep it at that scale for at least a month, like doing a monthly scale ups and scale downs, but you don't want to necessarily do it automatic. When it comes to applications that read data from these streams, they can be very easily scaled, usually. Like you have some sort of a, if you're deploying them, for example, on Kubernetes cluster, those applications, you could use horizontal pod autoscaler that has some rules, like if either a memory consumption, average memory consumption, or CPU utilization of your application pool is above some threshold, you automatically trigger a webhook that scales application, then scales it down once it drops below the threshold. So usually the compute part is the easiest to scale. Right?
I see. Yeah.
And can be done automatically.
Okay.
And those nudges, like best practices, you should probably enforce them right from the beginning and forget about them.
Okay.
Like the file sizes, file formats, and similar. Partitioning, etc.
Yeah. And at point when you mentioned about data contracts, right? So data contracts are done in tandem with data science team or somebody who is a consumer. For example, data scientists are going to have that data piped in, which they'll use for modeling practices, right? But if your consumer of the data is working on a project which is iterative by nature, which is the modeling part, not everything is being sorted out in the first place, where you don't know is the data that you are getting today for which you're signing up for is enough for your next iteration of the model. And if that bounds to change and that requirement comes back to you for making those modifications in the data contract, how easy or difficult it is to do that?
So when you say data contract, probably there are multiple of things that are included in it. So the industry hasn't yet decided what data contract actually means fully.
Okay. So let's first define that.
Yeah,
Like,
so
what is the
it's just
loosest? Yeah.
it's just an agreement between producers and consumers, and it can take many shapes. It could be an Excel file, it could be API level, so it could be programmed, right? So it will include naturally schema, but schema is something that we have been checking for the entire last decade probably and more. So schema always has to comply, but then there are things like semantic meaning of the data, what this data actually represents and how it should be used. And SLAs could be also included in the contract itself, and then it could be extracted by different systems. Usually SLAs would be extracted by batch systems. But what if I understand your question correctly, you're still mostly focusing about schema part of it. So if the data changes, how do we deal with it, right?
Yeah.
So it will depend as well on the system you're working against, but you will usually send your events with the schema that they are represented by. So you will always have events of your data model evolving, always. You can't avoid that. So for example, I've worked quite a lot with web tracking data. So let's say user click in your website, and then how do you ensure that the schema of that event that's being sent out is correct? So I can tell you that it would evolve every 2 weeks, for example. It will always change. Like either an additional field will be added, or even backwards incompatible changes will happen. So you will version your schema. You will most likely start at version 1. And it will contain the things that you think you need, so that the developers can actually start sending them out. And probably very soon you will need to add additional fields. So you would introduce schema 1.0.1, 1.0. Actually 1.1.0, 1.2.0, etc. Because the last digit is for small batches. So let's say you released additional field, but something is wrong with it. So you would patch it a little bit. And the schema is propagated throughout the entire pipeline. So each event would hold it, and it can be validated against in your streaming pipelines. And that's what would be done usually. You would have a separate application that reads your event, which is considered a raw event. So it only consists, for example, a JSON, which is the event that you're interested in, and it will have a schema version that the producer says it should comply with. And then you have a process that also has a connection to a schema registry where you actually hold the schemas. And then you just pull down the schema, you validate that event against the schema. If it's okay, then you just push it down the stream. If it's not, you penalize it, put it into a different Kafka topic, where then either, usually what I think who should take care of this is the consumer, because he produced the incorrect data. But The sad reality is that usually data engineers that manage the pipeline are eventually
Yeah,
responsible. So they extract
I
it,
know.
they see what's wrong, they contact the developer who produced it, and maybe they patch it. You could patch it. For example, if the producer sent a JSON which has a string instead of integer, as you agreed, you could still extract it, change it into a integer if it's
Yeah.
just a number in string, and then push that event back into the beginning of the pipeline and fix it
Okay.
that way. But it should be responsibility of the producer to ensure that it doesn't happen. And then you
Yeah.
get those events with different schemas into your either data lake or data warehouse. And then there are ways of how to model it, either adding additional columns to the table or actually creating a separate table if the schemas are incompatible. Like we are changing names of the fields and everything completely, right? So you can't have it in a single table. Then you would have multiple tables and then you combine them somehow. But that you do probably in the data warehouse, actually.
Yeah. All right. So I think just last question, because I didn't even realize that we've been having this discussion for a long time. But because the topic or the theme of the podcast is scale, Aurimas. So I'll probably like to hear more from you about the system design choices that should be made, or one should be having a trade-off based of mindset which is required for a scalable data architecture. How do you prepare an architecture which can scale well?
So when you say data architecture, you mean specifically the data pipeline, or are you talking about machine learning deployments as well? Because
Right now
these
it's a
are
data
different.
pipeline. Yeah, it's data pipelines.
So if it needs to scale, because you usually don't start with a scalable architecture. If you're a
Yeah.
small company, don't do it. Just take your database dumps, load them into data warehouse, and work in that way. If we are starting to talk about scale, there are not that many choices to do. You will always need to have a distributed queue, right? So
Okay.
you choose either it's a cloud offering or you want to do it in-house. In-house, there are several solutions. So Kafka or Pulsar or Red Pandas. Currently, Red Pandas is the fastest. It fully implements Kafka's API, but Kafka is oldest and still kind of the most popular and will be the most popular, I believe, for the next 100 years. So then you
Yeah.
choose either you want to have Confluent in-house or you want to deploy it yourself. But there is kind of no-brainer that you need to have it, one of the solutions.
Yeah.
The application part that reads from Kafka, you will also have that always. You can either also use a managed service, which is usually serverless, so you don't need to bother about deploying it. For example, Kinesis has Kinesis Analytics, Kinesis Data Streams. Data Streams is the Kinesis itself, kind of. But you have ways both to push data into S3, for example, and into data warehouse, and even do transformations on top of it. So you choose either that or some very low level language, not necessarily low level, but something that you will need to implement a lot by yourself, like Kafka Streams. Not even Streams, but Kafka Consumers Producers.
Yeah.
Streams is already quite high level. Or you can use some distributed framework like Spark or Flink to do that. I would, in most cases, use either actually Flink, but Spark streaming is also really, really popular. So they scale almost endlessly. So if you choose it, you will not be choosing your own thing because it's just like the most scalable thing that we currently have, right? S3, those object storages, they are also very kind of limitless almost. We have some limitations in their APIs. So for example, how many files you can write how many requests you can do against it in 1 second, for example. So you could start bottlenecking at some point in time. But if you are dealing with correct sizes of data that you're pushing into it, it shouldn't be a problem. Of course, if you're on-prem, you might be thinking about doing your HDFS clusters, but now there are different solutions for that. Like you could still do a object storage in-house. So there are solutions like MinIO or Ceph. They implement S3 compatible interfaces on-prem, so you can have object storages on-prem as well. On top of which you can also use the metadata management layers like Hoodie, Iceberg, and Delta. When it comes to the data warehouse, all of the cloud data warehouses are suitable for scale. I'll kind of worked with most of them, like BigQuery, Redshift, and Snowflake. Touched all of them. Can say that the Snowflake is the most expensive one, but the Redshift has its own limits. Like you still need to deploy. Now Redshift also has some auto-scaling capabilities, but when I worked with it, it was really static. So you need to decide how many servers you want to have and scale accordingly. While Snowflake Snowflake stores the data in S3 basically, and you have not in the regular S3, they do some transformations on top of the data that they store, but you have a compute which is extremely scalable, right? So you only pay once you do querying.
Yeah.
Am I missing something from pipeline side? Connecting databases with, yes, so a good point. Connecting databases with your CDC streams. There are things that you need to consider. So anything that you do against your database is consuming part of a database resources, right? But I think CDC streams incorporated correctly, like using the Debezium and similar technologies, we are the least invasive because we are actually reading the commit log instead of actually querying the database itself. So we are not causing like bursts of load on your database at a certain point in time, which some of the solutions like polling could do.
Yeah.
Cool thing about them is that, for example, Flink supports Debezium connectors by itself. So you could even write a Flink application against your database that would capture CDC events from it instead of actually using Debezium itself. But you need to talk with your backend developers before you mount anything on the backend database. And then if it comes to collecting events from the public internet, for example, exposing the endpoint to the public internet so that events can reach So, for example, if you're dealing with IoT, you will most likely have some sort of the application that allows you to collect the events that you send over the internet.
Yeah.
So you need to have strong enough load balancer there because those events can be a lot. You also need a CDN facing it, not necessarily CDN, but something that would allow you to prevent DDoS attacks. But this is like software engineering more of it than data engineering itself.
Yeah.
And you need to make your collector scalable as well. So usually there will be a load balancer, and then you will have most likely Java applications that collect those events and push them downstream. So they need to be scalable specifically due to the reason that if you lose any events at this point, you basically lose them forever. You can't reprocess them. So you need those applications to be able to buffer some events in memory in case, let's say, downstream Kafkas start misbehaving. And you need the ability so that those applications could then automatically scale up if something bad happens or if there's a huge burst of traffic, which can happen as well.
Yeah.
During Black Friday, for example.
Yeah, I think that's what the whole stress testing of the system happens.
Yeah, of course. I didn't touch upon the actual organizational scale of it, right? So you need to have orchestrators in place that would allow you to construct DAGs and schedule them, because if you have a lot of data, not in the amount of data, but in the amount of difference in that data, like there could easily be several hundred pipelines that run daily. So how do you manage that scale? How do you manage the alerts that are coming in? What are the procedures to fix some stuff that is breaking? Like, how do you prioritize that? Which alerts are red, which are yellow, which are green, and nice to fix? Which data is of the most critical quality? Like what data products are the ones that are driving your business? You need to understand how, like, if this breaks, then you lose, let's say, 10 million in a day, right? There could be these kinds of cases, and then there are products that are nice to have. So
true.
Yeah.
No, absolutely. I think that's quite a bit of information. But now that we are about to close the episode, I just want to, like, at one point when you mentioned about choosing between the two options, for example, when we are talking about distributed framework, between Flink or Spark, which one would you choose? And is why one is a preference over the other? When you gave an example of, for example, Redshift versus Snowflake, knowing that when you used to use Redshift, there was no option of auto scaling or those kind of things, right? So what all parameters should one think of while comparing between multiple options? I know that there is no one general answer to this, because it a lot depends on, the use case you're working for and what the requirements you are solving, the whole, or maybe designing the whole pipeline or the architecture. But some go-to steps that you want to quickly wrap up with the episode. Yeah.
So then when, for example, it comes to streaming applications, so let's say taking Flink versus Spark.
Yeah.
So first, of course, we need to understand what our developers are familiar with.
Okay.
Because learning new technology will cost you a lot, and a lot more than you think.
Yeah.
Then the medium on which you are actually deploying applications. So do you have Kubernetes cluster or you don't? How mature is the technology? So in my opinion, Flink is still a better option to choose between these two, because it is more mature, older, even though Spark has a bigger community, right?
Okay.
So Spark also works on a micro batch level, whilst Flink is a real streaming not platform, it's actually a streaming framework.
Yeah.
Both of them kind of starts a cluster to do what we do. But I think the Flink's cluster manager system and restart capabilities of a application that went down is better, because it actually saves both the state of the application that does any aggregations and the checkpoint. So basically, if your application goes down and it does some large enough compute as in aggregations, it is able to very quickly restart. As an example, for example, Kafka Streams wouldn't be able to do that, because Kafka Streams would need to restart and recompute the state. Unless, of course, you have it in your application that you manage the state in the database of some sort, right?
Okay.
What else? So probably I would consider naturally how much data it is able to process and how easy it is to scale the cluster. What language is it written in? What interfaces are available?
Yeah.
Community already mentioned. Yeah, I would guess that's almost enough. Of course, the capabilities of the API itself. What transformations can it do? How easily is it? A very important thing. How easy it is to integrate that specific framework with our data storage solutions.
Yeah, I think that's quite a bit. And I've just, based on my experience so far, these were the points that always used to come upon as the key quick factors to evaluate which one do we want to really go ahead with. And, that's the kind of information, in fact, I was also looking for somebody who is new to this and would want to take a step back and understand, because once you kind of, do you also believe that once you choose one and then later you think that maybe this is not the best suited one that I should have gone ahead with, being logged in with a particular vendor or the service provider becomes a challenge then to migrate to?
Yes, it depends on which, but yes, generally that is true.
Yeah.
Generally that is true.
Yeah.
It also depends on how much time you have already spent
Yes.
using
Yeah.
that framework. But
Correct.
migrations are painful and they are in a sense useless, right? Because we don't provide any value to your business. And it could happen, like I participated in migrations of data warehouses, for example, and they are painful. They can take years.
Yeah.
And you're not generating that much value from the things that you do. And not only not generating value, but you are missing an opportunity to generate additional value while you are actually doing the useless work.
Yeah, and I think the challenges of migration are many, and it's kind of an unnecessary overhead, I can say, on the team when you're doing this. So that's what I'm just thinking, that the time that you end up spending in migrations, is there a way that you can think of them through while you're taking that first call so that you save them from that extra trouble?
So not even the first call, but I would encourage people not to get stuck on their decisions that were wrong, right? So there could be cases where you actually did a wrong decision, you implemented few applications, see that they don't work, and then you continue using the framework while you could just do it, switch
at the right time
as soon as possible. Yeah. For having too much technical debt.
Yeah, I think
that's called
this is kind of
sunk cost fallacy, right?
I was about to say that. Yeah. Now that you're stuck into that, you're kind of just postponing that decision because you want to ensure that there's a sunk cost already that are spent into maintaining it or, working on this. And then that becomes your technical debt later.